Hello students, this is a video on the topic test for quant available on Bodhee Prep. The idea of these tests is once you have covered the basic concepts of a test, you can test basic concepts of a topic and you can test yourself and see whether you're able to use those concepts in an exam setting or not by taking these tests. Once you take the test, that is when you refer to this video. This video gives you the solutions of the questions and also brief analysis of how the test should have been taken in terms of number of questions and time for the test. There are more than 200 such topic tests and videos available on the Bodhee Prep Android app. The link for the app is in the description of the video. So make sure you download the app and make the most use of these tests. This video is on the topic logarithm, and we're discussing the first test on logarithm in the app. Overall, I think it's a moderate level of difficulty test with about 6 questions being a good attempt. 6 questions net correct. So that would give you a 95 plus percentile. And I think the attempt time for this test should be somewhere around 21 to 24 minutes. That is going through the 10 questions and finding the 6 questions for ourselves. If we are doing it like a timed exam. If you look at the questions, the first question says 2 raised to power 6x plus 2 raised to power 3x plus 2 minus 21 is 0. Whenever we have a term like this, what we do is we take one part common and try to write it as a quadratic equation. So 6x can be written as 3x into 2 plus 2 raised to power 3x plus 2 will be nothing but 2 raised to power 3x into 2 raised to power 2. So this becomes plus 4 into 2 raised to power 3x minus 21 is 0. Let 2 raised to power 3x be y. So this equation becomes y square plus 4y minus 21 is 0. 7 3 is 20. So this can be written as y plus 7 into y minus 3. Difference for product 21 is 0, which means either y is equal to minus 7 or y is equal to 3. Y is nothing but 2 raised to power 3x. Clearly, 2 raised to power 3x cannot be a negative term, so this solution is rejected. We get 2 raised to power 3x is equal to 3. We take the log on both sides. So log of 2 raised to power 3x to the base 2 is equal to log of 3 to the base 2. 3x then comes in front. Log of 2 to the base 2 is 1. This is equal to log of 3 to the base 2. And therefore x is nothing but log of 3 to the base 2 upon 3. Option C becomes the answer. I think it's a standard format of question and log in terms of level of difficulty moderate. Since the numbers are easy, you should be able to do this in about 2 minutes time. Let a be a real number. The roots of the equation x square minus 4x minus log a to the base 2 is 0 are real and distinct. The roots of a quadratic equation are real and distinct if the discriminant is greater than 0. At equal to 0, the roots are not distinct. At less than 0, they are not real. So here b square minus 4ac, discriminant should be greater than 0, which means minus 4 square minus 4 into 1 into minus log a to the base 2 is greater than 0, which means 16 minus 4 log a to the base 2 is greater than 0, which means 4 log a to the base 2 is less than 16 divided by 4. Log a to the base 2 is less than 4. And therefore, this will become positive. So minus minus, so we'll write 4 log a to the base 2 is greater than minus 16, which means log of a to the base 2 is greater than minus 4 divided by 4. This is what we get. And therefore, a has to be greater than 2 raised to power minus 4, which is nothing but 1 by 2 raised to power 4. And therefore, a has to be greater than 2, 4, 8, 16. Option A becomes the answer. I think this is a straightforward question unless you don't make a calculation error. Should be able to do this within about a minute and a half. Let x be a real number, then root of log of 4x minus x square upon 3 to the base is a real number if and only if. Now, the number under the root should not be negative. So this should be positive, greater than equal to 0. And this will be 0 when the value for which we are taking log is 1, greater than equal to 1. E raised to power 0 is 1. So 4x minus x square upon 3 should be greater than equal to 1, which means 4x minus x square should be greater than equal to 3, which means 0 should be greater than equal to x square minus 4x plus 3. X square minus 4x plus 3 is less than equal to 0. Sum of 4, product of 3. X minus 3 into x minus 1 should be less than equal to 0. Critical points become 1 and 3. Positive, negative, positive. We are looking at negative values, and therefore 1 less than equal to x less than equal to 3. Option C becomes my answer. Again, I think moderate level of difficulty question, because putting the value of this term, and since the e is also there, can get a little confusing. Otherwise, about 2 minutes to solve the question. Log of x to the base y is equal to a times log of z to y to the base z is equal to b times log of z to the base x is equal to ab. Which of the following pairs of values for ab is not possible? So here we can say a log y to the base z is equal to ab, which means log of y to the base z is equal to b. Similarly, b log z to the base x is equal to ab, which means log of z to the base x is equal to a. Now, if we multiply these two, we can say log of y to the base z into log of z to the base x is equal to a into b, which means log of y upon log of z into log of z upon log of x is equal to ab, which gives us log of y upon log of x is log z cancel is equal to ab. We also know that from the initial equation, log of x to the base y is equal to ab, which can be written as log of x upon log of y. Wherever the base is not there, we can take the base as 10, equal to ab. So this is equation 1, this is equation 2. If we multiply 1 and 2, we'll get log of y by log of x into log of x by log of y will be ab into ab, which means these get cancelled out. AB square is equal to 1, which means taking the square root, AB has to be either plus 1 or minus 1. From the first option, if you multiply, we get minus 1. Here we get 1. Here we get 1. In option C, 2 into 2 is 4. So A and B cannot be 2 and 2 because their product has to be either plus 1 or minus 1. In terms of level of difficulty for this question, I'd say maybe moderate to difficult, because there is some amount of change that has to be made. But I think if we multiply, it becomes pretty easy to solve. And therefore, maybe 2 to 2.5 minutes to solve the question. And in terms of level of difficulty also, stick to moderate because the terms are simple. Log of 81 to the base 12 is equal to p, then 3 minus 4p upon 3 into 4 minus p upon 4 plus p is equal to. So I want to get a 4 from here and then use some sort of component or dividend to get this kind of a term. That is how I'm starting. So I'm writing p as log of 81 to the base 3 upon log of 12 to the base 3. The numerator becomes 4. This becomes log of 12 to the base 3 is equal to p. Now what we can do is, we can add and subtract. Or we get 4 by p. 4 by p comes out to log of 12 to the base 3. And therefore, if you use component or dividend, we can write 4 plus p upon 4 minus p is equal to log of 12 by 3 plus 1 upon log of 12 by 3 minus 1. And therefore, if we take the reciprocal, 4 minus p upon 4 plus p will be log of 3. 12 minus 1 upon log of 12, 3 plus 1. Now, this can be written as log of 12 to the base 3 minus log of 3 to the base 3 upon log of 12 to the base 3 plus log of 3 to the base 3. This further can be written as log of 12 by 3 to the base 3 upon log of 12 into 3 to the base 3. Log of a into b is log of a plus b, log of a divided by b is log of a minus b. This becomes log of 4 to the base 3 upon log of 36 to the base 3. And therefore 4 minus p upon 4 plus p is nothing but log of 4 to the base 36. This further can be written as log of 4 becomes 2 squared. Log of 36 becomes 6 squared. Taking the roots out, 6 squared, 1 by 2 comes out, 2 squared, 2 comes out, we get log of 2 to the base 6. And therefore 4 minus p upon 4 plus p is log of 2 to the base 6 multiplied by 3. 3 into 4 minus p upon 4 plus p will become 3 into log of 2 to the base 6. Taking 3 to the power of 2, we get log of 2 cubed to the base 6. And therefore my answer becomes log of 8 to the base 6. Option B. The rearrangement here is a little difficult, and therefore I'm saying attempt time would be higher, but always try to work with the constant rather than the log term. It is easier, because if you're splitting the log term, this becomes a little complicated otherwise. Putting this value here and then trying to solve will be a little more complicated, and therefore about 2.5 minutes to solve. But because basic properties are being used, therefore I'm saying moderate level of difficulty. Log of 1 plus log of 1 plus 3 plus log of 1 plus 3 plus 5 up till log of 1 plus 3 plus 5 till 19 minus twice of log of 1, log of 2, log of 3 up to log of 7 is m of nx plus ay. Log 2 is x, log 3 is y. Which of the following is the ordered triplet? Base 10 whether the for all logarithmic functions. So let us look at the first positive term here. This is log of 1 plus 1 plus 3 is log of 4. 1 plus 3 plus 5 is log of 9, and so on. Now the sum of the first n odd numbers is equal to n square. So here if you look at it, this is the sum of the first 10 odd numbers. And this will therefore come out to log of 10 square, which is 100. The second term minus 2 log of 1, log of 2, and so on up till log of 7. This can be written as log of 1 square plus log of 2 square plus log of 3 square and so on till log of 10 square minus 2 times of log of 1, log of 2, log of 3 and so on. From here the 2 comes out, so 2 log 1 plus 2 log 2 plus 2 log 3 and so on till 2 log 10 minus 2 log 1 minus 2 log 2 and so on till 2 log 7. So what will be left with here is the 1 and 1 term will cancel, 2 and 2 term will cancel, 3 and 3 term will cancel, and so on. We will be left with 2 log 8, 2 log 9, 2 log 10. Log 10 we know is 1 because of the base 1. 2 log 8 is 2 log 2 to the base 3. This is log 9. 2 log 3 to the base 3 square. Log of 2 cube, twice of log of 2 cube plus twice of log of 3 square plus log 10 is equal to 1, therefore 2. This becomes 3 to the 6 log 2 plus 4 log 3 plus 2. I'm writing 2 in front. And therefore this is nothing but 2. Log 2 was x. Therefore 2 plus 6x. Log 3 was y. Therefore plus 4y. This equation on the left hand side is given equal to m plus nx plus ay. Therefore m becomes 2, n becomes 6, a becomes 4. 2, 6, 4, option A becomes my answer. Again, even if we do not know that the sum of the first n odd numbers is n square, by adding we'll get the pattern, and then once the 2 cancels out, it should not be very difficult to solve. So about 2 minutes to figure the first part out. Then I think 2 or 3 steps we get the answer. About 2 to 2.5 minutes to solve, moderate level of difficulty. X and y real numbers such that 2 log x minus 2y is equal to log x plus log y. We can take the 2 as the power and write it as log of x minus 2y square is equal to log of a plus b is log of a plus log of b is log of a into b. Since we have log on both sides, we can say x minus 2y whole square is equal to xy, which means x square plus 4y square minus 4xy is equal to xy, which means x square minus 5xy plus 4y square is equal to 0. We have to find x by y. If we divide the entire thing by xy square, by y square, we get x square by y square minus 5xy upon y square plus 4y square upon y square. This becomes x by y whole square minus 5x by y plus 4, which is nothing but x by y minus 4 into x by y minus 1. Sum of 5, product of 4 is 0, which means x by y is equal to 4 or x by y is equal to 1. Now, if x by y is equal to 1, we will get x is equal to y, which means x minus y will be 0, and therefore x minus 2y will be negative. This should not be negative, and therefore this solution is not possible. Option B becomes my answer, 4. This question I think could be tricky because once we get 4 and 1, there is a possibility we do not check for 1 and mark C as the option. So this is a question where the probability of a negative mark is very high. In any case, easily 2.5 minutes to solve and moderate to difficult or maybe a tricky question in that sense. Log of x to the base 3 log of x to the base 4 is equal to log of 7x to the base 4. How many real solutions exist? This can be written as log of x to the base 4, log of x cube to the base 4, taking 3 at the top, is equal to log of 7x to the base 4, which means x cube is equal to 7x, which means either x is equal to 0 or x square is equal to 7. How many real solutions? X is equal to 0 or x is equal to root of 7 plus minus root of 7. Zero is not possible because here x cube cannot be 0. 4 raised to power any value is not 0. 0 will not be counted. We get x square as 7. So we can have x as root 7 or x as minus root 7. Again, negative value is also not possible. So this solution will also not be counted. The only possible solution is x is equal to root 7. Again, because solutions have to be eliminated, therefore I'm saying becomes a little tricky question, about 2 minutes to solve. Log of 5a plus log of a to the base 3 to the base 2 is 3, and log of 4a plus 12 plus log of b to the base 2 to the base 5 is 3 again. We have to find a plus b. So first let's operate from here. We can say 2 raised to power 3, 5 plus, by definition, log of a to the base 3 is equal to 2 cubed, which is 8. Subtracting 5 from both sides, log of a to the base 3 will come out to 8 minus 5, which means log of a to the base 3 is equal to 3, which means a is 3 to the power 3, which is 27. Putting that value here, log of 4a, 4 into 27 plus 12 plus log of b to the base 2 to the base 5 is equal to 3. By definition, we can take 5 cubes of 4 into 27. 108 plus 12 plus log of b to the base 2 is equal to 5 cube. This becomes 120. So log of b to the base 2 is 125. 5 cube minus 108 plus 12, which is 120. So log of b to the base 2 is nothing but 5. And therefore b is equal to 2 raised to power 5, which is 32. 2, 4, 8, 16, 32. And therefore A plus B will be nothing but 27 plus 32, which comes out to 59. This I think is a relatively easier question because basic property of log or basic definition of log is used, and we don't even require the properties to solve this. But since the calculation is involved and there are 2, 3 steps, therefore I'm saying maybe an easy to moderate level of difficulty question, the attempt time might be higher. If 5 raised to power log of x to the base 10 is equal to 50 minus x raised to power log of 5 to the base 10, find the value of x. Now here, if we have a raised to power log of b, this can be written as b raised to power log of a. So here we interchange x and 5, we write it as x. This is a property that I'm using. X raised to power log of 5 to the base 10 is equal to 50 minus x raised to power log of 5 to the base 10, which means x raised 2 into x raised to power log of 5 to the base 10 is equal to 50, which means x raised to power log of 5 to the base 10 is equal to 25. Again, I'm interchanging these two. So 5 raised to power log of x to the power 10 is equal to 25, which is 5 square, which means log of x to the power to the base 10 is equal to 2, which means x is equal to 10 square or 100. Option C becomes my answer. This answer is moderate to maybe higher level of difficulty because the property that has been used may not be a property that all of us are very comfortable with, or something that strikes in the first go, and therefore moderate to difficult, but attempt time will not be very high. So if we look at the overall test, moderate, 24 minutes, 6 questions. If I had to choose my 6 questions, they would be 1, 2, 3, 6, 7, 9. Which are these? I would count this as an attempt because it's a standard question. Similarly here, basic discriminant 0, getting the answer. This one also, as long as I know that I have to put the log value greater than equal to 1, should not be very difficult to solve. Here, some amount of rearrangement is required, so not counting this as the easier 6. This one also requires rearrangement, not counting it as the easier 6. This one I think was pretty easy. The moment we get the fact that the first terms are squares, everything else kind of follows from there. This one also I think was not very difficult. Basic properties were used, and then we were left with the quadratic, which can be managed. Here, because we're eliminating the solution that we're getting, therefore I'm saying a bit tricky. This one should not have been difficult. Basic definition of log is used to solve this. Here again, because the property used was a little not very ordinary property, so not counting this is one of the easier 6, and therefore my 6 short questions would be 1, 2, 3, 6, 7, and 9.